So now we will discuss about the physical properties of alcohols and phenols. Physical properties of alcohols and phenols. So under this, we will discuss about boiling point of alcohols and phenols. Number 2 is solubility. So if you see the boiling point or solubility, whatever it may be, the main reason for the particular property of alcohols as well as phenols is only hydroxyl group. So hydroxyl group is responsible for the properties of the alcohols as well as the phenols. So hydroxyl group is the prominent one. So then if you see the alcohol as well as phenol structure, it will contain two parts, right? One is hydroxyl group. Two parts are there. One is hydroxyl group. Another one is either alkyl group or aryl group. Right? So this will be in, I can say, hydrophobic in nature. Means they won't be miscible with water. So they will make some distance with the water. Means they don't like water. They're resistant to water. But hydroxyl group is a polar polar in nature. Hydroxyl group will be hydrophilic in nature. Hydrophilic in nature. So this is important thing what you have to remember while studying the boiling point as well as solubility. So we have two parts of the alcohols and phenols. One is polar in nature and hydrophilic in nature. This is polar and this is non-polar and hydrophobic in nature. They don't like water, we can say in that manner. We come to boiling point. So boiling point of alcohols, usually if hydrocarbon chain, SC chain, increases in carbon number, its boiling point increases. Its boiling point also increases. Suppose you can say, for example, 1 carbon alcohol, 2 carbon alcohol, or 3 carbon alcohol. So this is 3 carbon alcohol, 2 carbon alcohol, and 1 carbon alcohol. So methanol, ethanol, meth, eth, and pro. So whose boiling point will be more? So as per the condition, if in a hydrocarbon chain, if number of carbon atoms increases, 1, 2, here 1, 2, 3. This is a normal hydrocarbon chain, right? What difference we are observing? Here only 1 carbon is there. Here 2, here 3. So carbon number is increasing in the respective alcohol. So what will happen? Because of increase in the number of carbon atoms, boiling point is increasing. What is the reason for this one? If carbon number increases, what will happen means surface area of the molecule increases. Area of molecule also increases. If surface area increases, van der Waals force of attraction increases. increases. So what will happen finally? If van der Waals forces increases, boiling point increases. Boiling point also increases. So this is one important point what we have to review about why increase in the number of carbon atoms in a straight chain, especially in a straight chain. Alcohols, in alcohols, hydrocarbon chain increases in carbon number. Its BP will also increase. What is the reason? This is the reason. So finally, van der Waals forces increases due to increase in the number of carbon atoms because of increase in the surface area. So that is the reason. Next important point here. Instead of straight chain carbon number improvement, I can say number of carbons, if it increases in a straight chain, that will improve the boiling point. Instead of that, if branching increases, branching of HC chain, hydrocarbon chain of alcohols increases, what will happen? If branching of hydrocarbon chains of alcohol increases, boiling point decreases. If it increases, boiling point decreases. Reason is increase in branching. Decreases surface area. Yes, sir. Decreases surface area, decreases van der Waals forces. Decrease in van der Waals forces of attraction, you can say VF, VWF, decreases boiling point. So this is the reason. So basically what you have to remember is if branching increases in hydrocarbon chain of alcohols, so definitely BP will decrease. If branching increases, surface area decreases, van der Waals forces decreases. So finally boiling point decreases. This is very, very important point to be remembered. So if you see how the boiling points of alcohols and phenols with other compounds whose masses are comparable to them. So if you see an alcohol with a hydrocarbon, normal hydrocarbon, or ether, or alkyl halide, or aryl halide, so means haloalkanes, I mean to say, having similar mass, but who will have more boiling point means only alcohols and phenols. Even though their mass is comparable to the respective compounds of hydrocarbons, haloalkanes, aryl halides, or ethers, or normal hydrocarbons, but they will have advantage over them. Reason is only one thing, they can form intermolecular hydrogen bonds where other compounds cannot form. So you can write like this. Alcohols and phenols have more boiling points. Alcohols and phenols have more BP, boiling points, when compared to other classes of compounds, when compared to other classes of compounds like hydrocarbons, C, and you can take ethers, alkyl halides, means Rx, right? So this is ROR, you can write. And aryl halides. Aryl halides. Aryl halides means benzene ring attached with halides. So X of comparable masses. Of comparable masses. So what this statement says means alcohols or phenols both will have greater BP boiling points when compared to remaining things. I mean hydrocarbons, ROR, RX and C6H5X. Or you can write the benzene ring, no problem. This is how it will happen. What is the reason for this? Alcohols and phenols can form intermolecular. Intermolecular means in between the molecules. Intermolecular hydrogen bonding. Intermolecular hydrogen bonding. I will show you one example. Suppose ROH. Intermolecular hydrogen bonding. So one more ROH you can take. One more ROH. Here one more ROH. So what will happen? This will try to interact with this one. This will try to interact with this one. This will interact with this one. And this oxygen will have interaction with this one. And this will also have interaction with this hydrogen. And this will also have interaction with this hydrogen. So like that, nearby alcohol molecules, because all will be together, right? One molecule's oxygen's lone pair will try to attract the hydrogen of another molecule, another alcohol molecule. So here also it is also having hydrogen, right? Its hydrogen is attracted by the lone pair electrons of the oxygen of the other molecule. This is how intermolecular hydrogen. In between two molecules, this is one molecule, this is another molecule. So hydrogen is acting as a bridge molecule. So this will make them very strong. So very strong means they will not evaporate easily. What is boiling point? Evaporation point is boiling point, right? If you start heating a liquid, at what temperature that liquid start evaporating, leaving its liquid phase into the gaseous state or vapor state. That evaporation point, vapor point is called boiling point. So if these are folded by each other, like a unity, togetherness. So togetherness of these alcohol molecules is brought up by the intermolecular hydrogen bonding, which is making them too difficult to become volatile. To become volatile. That's why they can't easily evaporate because of intermolecular hydrogen bonding. They can't easily evaporate because of this reason. So that boiling point, I mean, you have to heat more and more temperatures. You have to increase the temperatures, then only it will reach its evaporation point. Then it will become a vapor. Okay, if you see the phenols also like that. Phenol. So you can take like this phenol group OH. So here is another phenol. You can see. And have another phenol. So it will attract this hydrogen. This will attract this hydrogen. So like that, here also intermolecular. In between, this is one molecule. This is another molecule. These two are, I mean, bridged by the hydrogen bonds, attached by hydrogen. So I can write like this also if you want. OH. So another molecule is here. OH. OH. I mean to say we will write this side for this. OH. So this will be attracted by this one, this will be attracted by this. So like this, intermolecular hydrogen bonds are formed, which make the liquid to evaporate easily. So that will give the strength to increase the boiling point. Understand? No? So if you see here, I mean this slide, you can see here, ethanol, CH3, CH2, OH, right? The same thing, ethanol. And this is methoxymethane, alkoxyalkane. So CH3, OCH3. And propanone, propane. He has taken a hydrocarbon, propane. CH3, CH2, CH3, right? Propane. If you take these three, so ethanol is having the mass of 46. Molecular mass is 46 grams. Methoxymethane, 46 grams. And molecular mass of propane is 44 grams. Almost similar, right? All three are, only this is having 2 units less. But if you see the boiling points of alcohol, this is alcohol, right? It is showing 351 Kelvin temperature. And the boiling point of ether is 248 Kelvin, right? It is greater than ether. Alcohols are having more boiling point than ether. Then ethers are having more boiling point than normal hydrocarbon, 231 Kelvin. So which is leading highest one? Alcohol, ether, and hydrocarbon. Understand? So here we'll see the exemplar problem. So where he is asking us to arrange the compounds in the increasing order of their boiling points. So first one, we'll see the option A, where we have pentan 1 mole. So means pentan 1 mole. 4 carbon containing alcohol. Then butan 1 mole. Butan 2 mole. Means both are 4 carbon containing alcohols. 4 carbon, 4 carbon. So one is terminal alcohol, another one is primary alcohol, secondary alcohol it will come because it is attached to 2 carbons. So then ethanol, 2 carbon containing alcohol, pentanol, 5 carbon containing alcohol, then propan 1 mole, 3 carbon containing alcohol, then methanol, 1 carbon containing alcohol. So as we know, in an open chain, straight chain alcohols, straight chain containing hydrocarbon alcohols. If the number of carbon atoms increases in the hydrocarbon attached to hydroxyl group, alcoholic group, then definitely the boiling point of the respective alcohols whose carbon number is more will increase. So according to that, what will happen? So which will come last? Which is having less number of alcohols in the hydrocarbon chain, they will come the last because it is asking from the lower to higher, right? Increasing order. So what will happen? First, 1 carbon containing alcohol will come first. Which is 1 carbon containing alcohol? Methanol. So that's why we'll write methanol. So methanol will have less boiling point when compared to 2 carbon containing. So what is 2 carbon containing? Ethanol. Right? Then 3 carbon contain. Propan 1 mole. Right? Propanol. Propan 1 mole. So then we have 2 4 carbon containing alcohols. One is butan 1-vol, another one is butan 2-vol. But terminal alcohol groups, I mean alcohol group, if it is present at the terminal carbon, that will have more boiling point than the alcoholic group which is present on any other carbon. So in between carbons, I can say. So here if you take butan 2-vol will have less boiling point. Butan 2-vol will have less boiling point when compared to butan 1-vol. 1-vol. So this you have to remember. So if it comes like that, so I will write a note here. Okay. Hydrocarbons, carbons with the terminal hydroxyl group will show higher boiling point than any other alcohol with same number of carbon atoms. Same C number of carbon atoms. So this is what the reason. So this is the reason for this one. Butan 2-vol is having less boiling point when compared to butan 1-vol. That is the reason. Then if you come to another one, automatically highest will be pentan 1-vol because 5 carbon contain. Pentan 1-vol is the highest boiling point containing alcohol. So you understand, ma? This is 4 carbon, this is also 4 carbon, this is also 4 carbon, this is 5 carbon. So 5 carbon will have more boiling point. So if you write in reverse order, then 4 carbon, then 3 carbon, then 2 carbon, then 1 carbon. So this is one important thing what you have to remember. So he is checking the concept, what you have understood. Then pentan 1-vol, N-butane, pentanol, and ethoxy ethane. I'll write here. So what he is asking, so B is, I'll take this only completely. See, we are going to solve the B. So pentan 1-vol means 5 carbons will be there. N-butane 4 carbons. But this is an alcohol, this is hydrocarbon. This is alcohol, this is vol, right? Vol means alcohol. This is simply hydrocarbon chain. This is pentanol, 5 carbon containing all. All means aldehyde. Ethoxyethane. So alkoxyalkane. Oxyalkane. Oxyalkane. Alkoxyalkane. So this is ether, right? So you can write simply ether only here. Ether, right? So how you compare the boiling point among these groups? So usually we know, so reason is only one thing, why they will have differences. Intermolecular hydrogen bonding found by the alcohols and phenols, that we know. So pentanol will have highest boiling point among these groups. Then pentanol aldehydes will have. Then ether, then butane. So order will be first increasing order, right? N-butane. Because this is hydrocarbon. Hydrocarbons and ethoxyethane. Ethers cannot form intermolecular hydrogen bonding. So N-butane. Next one is pentanol. Next one is pentanol. No, ethoxyethane. Because it can also form little polar nature. Ethoxyethane. Ethane. Then pentanol. So then pentan 1 volt. Pentan 1 volt. So this is alcohol. So this is hydrocarbon. This is ether. This is aldehyde. This is the alcohol. You understand now? So finally, you can write one note here. Alcohols have more boiling point than hydrocarbons, ethers, aldehydes, ketones, and haloalkanes. Haloalkanes are aryl halides of comparable masses. Comparable BLE masses. This is the second option, how they have difference in their boiling points. Understand? So here we will see two more questions, which is given in exercise problems. So 11.4 you can see. Explain why propanol alcohol, I mean 3 carbon containing alcohol, right? Propanol means, so 3 carbons will be there here. Propanol means 3 carbon alcohol has higher boiling point than the hydrocarbon butane. Butane is 4 carbon, right? A simple reason. Alcohols will have more boiling point than hydrocarbons. So first preference is alcohols. Alcohols have more BP, greater BP, higher BP than hydrocarbons. Because of formation of intermolecular hydrogen bond. Intermolecular hydrogen bond. So this is the reason. Understand? This is 3 carbon, this is 4 carbon. So this will contain alcohol group. This is not having any alcohol group. That's why alcohols have more boiling point than hydrocarbon because of the formation of intermolecular hydrogen bond. So that is the reason for that. So give reason for the higher boiling point of ethanol in comparison to methoxymethane. Ethanol, again the same reason, ma. Ethanol can form intermolecular hydrogen bond. But methoxymethane, an ether, methoxymethane, which is an ether, cannot form hydrogen bond. Hydrogen bonds. This is the another explanation for the why phenol, why ethanols is having more boiling point when compared to methoxymethane. Because ethers cannot form intermolecular hydrogen, or cannot form intermolecular. You can write intermolecular here also. Molecular hydrogen bonds. That is the reason. So then we will move to solubility. Another physical property is solubility. So miscibility of any compound in water is called solubility, right? Uniform distribution of any compound or any liquid in water. Dispersion, equal dispersion, homogeneous dispersion of any compound, either liquid or solid or gas, in water is called solubility. So how alcohols and phenols are soluble in water? Suppose if you take alcohols and phenols, because of presence of hydroxyl group, I told you hydroxyl group is responsible for all the major properties of alcohols and phenols. Presence of alkyl and aryl group, just they will modify the properties. They are meant for only modification, but the property is because of the presence of hydroxyl group. So automatically both alcohols and phenols are soluble in water. Both alcohols and phenols are soluble in water. Because again the same thing, they can form intermolecular hydrogen bonds. Intermolecular hydrogen bonds. Understand? So this is the important point to be remembered. Alcohols, phenols, both alcohols and phenols are soluble in water because they can form intermolecular hydrogen bonds. So that intermolecular hydrogen bonding I have shown you right already. So how it will form? Suppose if you take an alcohol, ROH. So water molecule structure will be OH, right? Another alcohol you take. So this oxygen will start forming a intermolecular hydrogen bonding like this. So here in between these two, hydrogen and this one, another intermolecular hydrogen bond is formed. Suppose if you have another OH molecule, OH2, H2O molecule here, what will happen now? So this oxygen will form intermolecular hydrogen bond with this one, and this hydrogen will form intermolecular bonding with this one. Again, this oxygen will form. Anyhow, intermolecular hydrogen bonding will be there in between water molecules. So like that, again, if you draw another alcohol here, so it will attract this hydrogen. This oxygen will attract this hydrogen. Like this intermolecular. Intermolecular means two molecules. So one molecule is alcohol, another molecule is water. Water molecule. In between water and alcohol molecules, hydrogen bonds are formed. Alcohol, intermolecular hydrogen bond is found between water. So this is one molecule, this is another molecule. We have hydrogen bond here. Because of this reason, they are soluble in water. So one more point is interesting. Will all type of alcohols and phenols are soluble in water? No. Important point. Will all types of alcohols and phenols are soluble in water? Answer is no. Reason is increase in the chain length of alcohols decreases the solubility of alcohols. Even phenols also, heaviness of the phenols. So this is the reason. What it means, you can see here. I told you here. Suppose CH3OH, C2H5OH, C3H8OH. Like, so this will be easily soluble. Solubility, if we take order, it will be more soluble than ethanol. Ethanol will be more soluble than ethanol. Like that, C4. So hydrocarbon chain increases, hydrophobic nature increases. Nature increases. So hydrophobic nature means water hating nature. It won't like water. It won't be miscible with water. So alcohols with more number of carbon atoms will show less solubility. Alcohols with more number of carbon atoms shows less solubility in water. Understand? That's why lower alcohols are easily soluble in water. So this is the important point what you have to remember. Understand? So whatever it may be, lower molecular mass containing alcohol. Lower alcohols means molecular mass is less, soluble in water, easily soluble in water, or easily miscible in water. You can say like that one. Understand?